So now, before we get into today's session, I want to bring us this particular interaction. You remember, I've been saying that I wanted to introduce elements of cryptocurrency into this space. So we'll just have a short introduction to cryptocurrencies, just as an opening section. I was going to do this later, but I'm a little bit concerned that the room might get out of hand and we might not have room for this slot. But I want this slot to come in and I want it to be a regular fixture. So somebody has been kind enough to put a package together to introduce us to the cryptocurrency space. So we go through that first and then we get into the session. Femi, it's good to see you. Femi? Femi, are you there? Hello, Femi?
Hi, Woman. Are you there?
Yeah. Hi, how are you? It's good to see you, and thank you for doing this. Are you ready for us?
Yes, I am actually.
So if you're ready, I'll just come off the screen, and then you can just do your bit, and then if there are any questions, then you take them later. Shall we do it that way?
Yeah, that's good. Before you go, there should be a way for me to share my screen, correct?
Well, if you know how to do it, because I don't know how to do it from here, so if you are able to do it your end, then that should be fine. Hello, have you muted yourself again?
I'm here. I'm trying to share the screen and just test it out.
Yes, I mean, I've seen somebody share their screen before, so you should be able to, because I can't share your screen from this end.
Oh, okay. Okay. All right, let's pick this. This is what I want to share.
So this is the new space now where the world is moving to. So you thank me later for this, but Femi, the floor is yours.
All right. Thank you, Oman. Good day, gentlemen and ladies. And thank you, Oman, for the opportunity for us to be able to share this session. I see this as a very important topic that needs to be addressed, and I think it's important in the sense that lately there've been a lot of people, a lot of hypes. Let me put it that way, in this space. And a lot of people just, based on what's going on in the news and all around them, they jump on the bandwagon. And from my experience, I know that that's always not always the best way to go about it. Essentially, it's important for us to educate ourselves, to have, in the simplest form of it, at least the most basic knowledge about any particular asset class or investment opportunity that we want to look into. And that's why this is a very important session that I think most of us will benefit from. And without wasting much of our time, I'll get into it. I'm hoping that I'll be able to rush through within the time allotted, but if we are unable to, maybe there will be a sequel to this. Okay, what we're going to be talking about really is the blockchain technology, and of course later on we'll get into cryptocurrencies.
Sorry to interrupt you, Femi. People are requesting that if you're able to, then you can show your face if you're able to.
I would not want to do that. They should.
Okay, carry on. But if you're looking at the comment section, that is what people are requesting. But carry on.
I don't feel comfortable doing that. If you can hear my voice and you can see the display, this is not a robot.
Okay, carry on.
Okay. All right. So let's get to it. Blockchain technology, and later on we'll be discussing cryptocurrencies as well. So quickly, we'll get into it. All right. So what is blockchain? we're going to be looking at how do they work, what problem or problems do they solve, and how can they be used. All right, those are the things we're going to be looking at quickly. And you can see, as you can see in the illustration there, we have a set of blocks that are interconnected by chains. All right, that's just simply put, blockchain. Right? So a quick background into it. A blockchain is a chain of blocks that contain information. So when we talk about block in the context of computer programming or cryptographics, all right, it's a computer protocol, a computer code, all right, that is mined or processed, all right, and it's just the word block is just a name that is given to such type of computer program or a transaction or a unit of computer item, all right? So it doesn't necessarily mean, physical building block or things like that. But of course, we know what I mean. Now, it is a distributed ledger that is completely open to anyone. Now, you need to pay attention to this. It is a distributed ledger that is completely open to anyone. All right, so back in the day, the banking system used to have ledger. Ledgers are like a register book, where if you went into a bank back then and deposit cash, your cashier or your banker will open to the current page for that day and put your name, put your account number, put the amount you deposited or withdrew, and put the balance on your account. That's essentially what your ledger is. So think of blockchain as a distributed ledger, meaning that one ledger that used to be, with that bank is now shared. That same ledger is shared with multiple banks, quote unquote now. The bank in this sense now are the nodes. Those are the nodes, which can also be referred to as miners. So each of the miners all over the world will have the same block, all right, on their distributed ledger for each transaction that they process. We'll get into details of that later on. It was originally described in 1991 by a group of researchers and was intended to timestamp digital documents so that it is not possible to backdate or to tamper with them. Now, that was the history as far as how it came about and what it was meant to do originally. It's a technology, and the application of it, in the later days or in the future, is yet to be seen. But at the point when it was developed, this was why it was developed, to timestamp digital documents so that it is not possible to backdate them or to tamper with them. All right. So last but not the least here is the technology was dormant until it was adopted by Satoshi Nakamoto in 2009 to create the digital currency called Bitcoin. So there wasn't so much application of that technology or use of the technology until 2009, when someone or a group of people pseudonamed Satoshi Nakamoto wrote a white paper, something called a white paper, essentially laying out a project, what it's going to be about, how it's going to run, what application is going to, how it's going to apply to daily use and all that. So we go to the next slide. Blockchain as a distributed ledger. So let's get into this a little bit. A blockchain has an interesting property. Once some data have been recorded inside a blockchain, it becomes very difficult to change it. Now, that is one very unique feature or characteristic of a blockchain. Once you have written a piece of information or entered some data into it, it's almost impossible. And I use the word intentionally. It is almost impossible to change it, because there is something called 5149 percentage, rule in the space. We can get into that later on. All right. And that takes us to the next slide. We continue on blockchain as a distributed ledger. So each block contains the following. Each block would contain data, hash of the block itself, that is the ID of that block, and hash of a previous block. All right, so as you can see in this diagram down here, you see you can have three things in a block. You have the data, you have the hash, and you have the hash of previous block. And this is all going to come together, as we go on. All right. The data that is stored inside a block depends on the type of blockchain. Example, the Bitcoin blockchain contains the following. So if you look at the Bitcoin blockchain, all you would see is from, to, the amount, and the timestamp. And of course, the timestamp will comprise things like the date, the time, actual chronological time of that transaction. And that's all you would see. So you have these four items in the example here, which is the Bitcoin blockchain. You have the from, you have the to, you have the amount, and you have the timestamp. All right. So that's the data for Bitcoin blockchain. Now, next, a block also contains a hash. I mentioned that earlier. You can compare a hash to a fingerprint. So a hash of a block is similar to your fingerprint. And we've been told, and we know that it's a fact that no two people have the same fingerprint all over the world. So this is the unique ID for a particular block. All right. It identifies a block and all of its content, and it's always unique, just as a fingerprint. Now, once a block is created, its hash has been calculated. Now, through cryptographic calculations, you can calculate the hash of a particular block. All right. Changing something inside the block will cause the hash to change. So if for whatever reason, and if it is possible to change any of the data, the hash, or any of the data in a particular block, you will have to change the hash as well, because then you have altered the content of that block. And so that original hash becomes invalid. You will have to change that as well, if it is possible at all. All right, so we go to next. The third element, hash of the previous block. All right, I mentioned that earlier. In a particular block, you have the data, the hash, and the hash of a previous block. This effectively creates a chain of blocks, and it's this technique that makes blockchain so secure. So basically what you have is a block that is connected to a previous block and has an ID or data of its own. All right, and that kind of forms a chain of blocks, and depending on how many blocks have been processed or mined for that particular period that you're considering, you can have multiple blocks in a particular blockchain. All right, now when you put all what I've gone through together, and you put all the original, the block, the data in the block, the hash of the block, and the hash of the previous block, you have this. As you can see here, this block 1 has the hash of 1Z8F, and the previous hash here is 0000. And I would expect that somebody will ask, why is this all 0? And the answer to that is because this is number 1, and that's called the origin, or the Genesis block. Just like you have in the Bible, the Genesis means the beginning block. All right, that's why you have, because it doesn't have any previous block here. So you have the hash to be all zeros. That's the Genesis block. Now, if you look at block number 2, it has this hash of 6-bit Q1. Look here, it also has hash of previous block, which is 1Z8F. which you can find here as well. And the same thing applies to block 3. Yeah, it has a unique hash of itself. It has a hash of 3H4Q. And if you look here, it has the hash of previous block, which is 6BQ1, just like this one. Now, if you put them together, you can now connect the previous block of block 1 to block 2, and then previous block of block 2 to block 3, and so on and so forth. You can keep connecting like that. That's essentially how the blockchain is built. All right. Okay. So tampering. I know a lot of people have this question that, okay, so you said blockchain is secure. How about, you know, it's computer, it's open to everybody. Somebody can hack it and do all, you know, what have you. But we're going to be looking at that very quickly. So the topic here is tampering. Tampering, essentially, of course, you're dealing with or poking into something, if I can use that as a lame word in the layman's language. So let's say we tamper with the second block, this block here. Let's say we tamper with that. This will cause the hash of this block to change, all right? Because I mentioned that earlier, remember. Now, in turn, that will make block 3 and the following block invalid because they no longer store a valid hash of previous block 2. See here, just if you tamper with this hash, tamper with this block and mess with the hash here, we change the hash from 6BQ1 to H62Y. It's gonna mess, you know, subsequent blocks up, like block 3, block 4, block 5, 6, and so on and so forth. All right, and that's what you have here. So any transaction up to this point will be valid, but after this point on block 2 will be invalid. All right, that's the effect of tampering with any blockchain. All right, let me flip to the next one. So we continue on tampering. Using hashes is not enough to prevent tampering because computers these days are super fast and can calculate millions of hashes per second. Hence, you can effectively tamper with a block and recalculate the hashes of other blocks to make the blockchain valid again. To mitigate this, blockchain has something called proof of work. So, you know, just like as I went through it, it sounded as if it's an easy task for somebody who is fast at this to do. Somebody can actually tamper with the block. However, in order to further solidify the security of blockchain, there's something called proof of work. And proof of work, what is it? It is a mechanism that slows down the creation of new blocks. So proof of work essentially slows down the rate at which a new block is generated. So that, for instance, as of today now, it takes approximately 10 minutes to generate a block in Bitcoin on Bitcoin network. So that's deliberate. That 10-minute approximate is a deliberate factor built into the code of Bitcoin. So that way, it will be like a big challenge for anybody who wants to attempt to alter or to tamper with the Bitcoin blockchain. All right. So we continue on tampering. For Bitcoin, it takes about 10 minutes. Yes, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. Adding a new block to the chain, let's go through this again. So this is the origin. This is block number 1, the Genesis block. All right. It would take approximately 10 minutes to generate or to mine block 2 and add it to the ledger to form a blockchain of 2 blocks. It would take approximately 10 minutes to generate block 3 to add it to block 2 and 1, you know, and so on and so forth. All right. So the mechanism of proof of work makes it very hard to tamper with the blocks because if you tamper with one block, you would need to recalculate the proof of work for all the following blocks. You see how it works now. So you can't just tamper with one. You will have to tamper with all subsequent blocks for you to make it legit. That's why it's kind of it's discouraged. You know, you are discouraged to to want to tamper with the blockchain, because you have millions of blocks as of today on the blockchain. So if you want to say hack it or break into it or tamper with it, essentially you'll be looking at recalculating the hash for each and every one of those blocks, which doesn't make sense really. All right. So security of blockchain. How much time do I have left?
Well, if you can round it off in a couple of minutes. I mean, this is something that will be ongoing, so you don't have to do the whole presentation in one session. It's just that I'm mindful that people are here for the politics, so yes. Yeah,
I'll stop on this slide. So let's just run through this, and then we can take it up from there next time. So security of the blockchain. The security of the blockchain comes from its creative use of hashing and proof of work mechanism. All right. So a combination of the hashing and the proof of work mechanism makes it very secure. You can't have either. You need to have both. If you want to recalculate the hash, then you need to show that your computer or your mining rig, you have spent some energy, which is power, electricity, to show your proof of work. Essentially, that's basically what it is. So if you want to recalculate that, do the math side of it. It's not something you do manually anyway. The computer does that, but then you'll have to also show the proof of work for all the subsequent blocks that you have tampered with. So this makes it very secure, and that's one of the unique features of the blockchain. Another way blockchain secures itself is by being distributed. I mentioned at the beginning that, remember the old school ledger book in maybe First Bank or those old bank, Wema Bank and all of them. Now you have that same ledger now distributed to all of these guys, this P2P network. So the image you have down here, these are actually, they represent miners all over the world, in Asia, Africa, Europe, wherever, all right, that are connected on the Bitcoin network, all right. So that hashing, that same ledger is distributed to all of these guys. So each of them has that ledger on their system, and they verify that ledger. Essentially, that's what they do when they mine. They verify the ledger to make sure it's correct before they add it to the blockchain. All right. So a transaction is broadcast into the network. The first person to pick it up will run it, and once the person has finished with it and everything checks out, he will then distribute it to others, and then they can add it on to the network, and they keep building on and on and on like that. I would stop here, and maybe if we have the opportunity next time, I'll continue with the material. Thank you, guys.
Thank you very much, Femi. So that is something that we're going to be doing a lot of, because I really want everybody to get up to speed with that space, which is the way of the future. In years to come, fairly quickly, in fact, cryptocurrency is something that you'll be spending in some form or the other alongside fiat money. I don't know how much Femi agrees with that or not, but that is the trajectory of it. So familiarize yourself with that. It's both transactable money and an asset source as well. So thank you, Femi. So introduction to cryptocurrency, you guys can go and make some money. Then maybe some of you can be using the what is it called? Some of you can go make some money so that some of you can be using the super chats like Alexander does, so go make money so that you can come and do super chat. Thank you, Femi. So we get back to the